We keep this pretty informal. So the way the Applied Climate program works is that the students give us a presentation on their projects at the end of each semester. And for Olivia and Michael, who will go first, this is kind of their end of the year project. So it'll be a little bit more involved. And some of the students are just kind of, Brian and Caitlin are sort of getting into their project. So Brian and Caitlin are going to present a little bit more about what they're planning to do. And Olivia and Michael are going to present more about what they have done because they are hopefully graduating, right?
Hopefully.
Allegedly.
And so if feel free to enter comments or questions in the chat, and we'll also after each talk where people can ask questions. But again, this is pretty informal. Like we don't need to be super formal about it. Feel free to ask clarifying questions during it, but we'll try and give the students opportunities to speak during their presentations. So I think our first presentation is going to be Olivia and Michael together and then separate. Yeah. And they'll get, because they're working on a little bit of a team project.
Yeah.
And of note, I'll just make a note, because we're trying to be respectful of everyone's time, we are not going to take any formal breaks with the exception of a 5-minute break in between presentations to allow for a transition. So if you need to step out of the room, obviously feel free to do that at any time.
Cool. And actually, just thanks for everyone who is attending either in person or virtually. I think it's very much appreciated.
Yeah, thank you to everyone for coming. So we're going to start off with a quick background on the project we're working on together, and then we're going to launch into sort of more in-depth separate presentations on each of our individual aspects of the project. So when we first started looking at what we're going to do for our Applied Climate Masters project, we both expressed interest in compound flooding, which is a physical phenomenon which happens when you have multiple flood drivers that occur at the same time. So you may have something like sea level rise and extreme precipitation and storm surge that all coincide to create more dramatic flooding than would have occurred should these things be taken in isolation. And this is especially prescient. Communities in the Great Lakes and on the coasts are increasingly vulnerable to these impacts. And so at the same time, there was a request for proposals from the NOAA Climate Program Office, and Lisa and our partners at the University of Georgia submitted a application, and Olivia will talk a little bit more about that.
Yeah, so just this was funded by NOAA CPO Climate Program Office. Michael just said it's a 4-year project.
Michael,
So
would you mind
Stepping away from your
yes,
slides.
sorry.
yeah, it's a 4-year project. So Michael and I obviously are not going to be here for this whole period. We just participated in helping writing a letter of intent and a proposal in the spring semester. So yeah, it works alongside the University of Georgia to implement scenario planning for coastal communities in Michigan and Georgia. And I'll talk about what that really means in my actual presentation. So yeah, it's just a little background on what we're both, the reason why both of our projects are the way they are. Awesome. So my project is titled Event-Based Scenario Planning to Inform Coastal Communities Adaptation Efforts. A little bit of similar to the scenario planning strategies that Lisa uses, but a little bit different, and I'll get into that in a minute. So a little bit more background on what I've been doing since January when I started in the MEng. Like I said, we both contributed to Lisa's proposal for the scenario planning project, and I spent some time also in the spring looking at the availability of climate data and how we can translate that climate data to more accessible data for decision makers to make adaptation choices. And I spent this semester looking at scenario planning and event-based scenario planning, analyzing the differences between the two of those. I also went to a conference earlier in November to talk about event-based scenario planning. I did a poster presentation there, and I'm currently finalizing a paper. So a little bit of motivation about why we chose this project. Climate models project rising sea levels and more extreme weather events for coastal communities, making the timeline for adaptation more critical, given that there's a lot of impacts and vulnerabilities in those regions. So in Georgia and South Carolina in particular, the increase in sea level ranges between 2 and 7 feet by 2100, which, if unprepared for, can significantly overwhelm infrastructure and threaten communities, especially if you plan for something like 2 feet and it ends up being 7 feet. You know, that's going to cause a lot of issues. So really, there's an explicit need for methods that can translate the numbers in ranges like 2 to 7 feet into actual information for decision makers to make choices about adaptation. So a little bit more background on these two locations. Coastal Georgia, like with the Glisa project, a lot of compound flooding risks, like Michael briefly mentioned earlier, which continue to be exacerbated by inequality and limited resources. Some of these are rural communities as well. And 57% of the properties in McIntosh County, which is a county on the coast of Georgia, is suspected to be affected by severe flooding in the next 30 years, which raises a lot of problems if people are interested in buying or developing property in that region. Charleston, South Carolina was also of interest given that there was a former master's project that looked at event-based scenario planning in that region. So along the eastern seaboard, there's a lot of hurricanes recently, especially ones that cause billions of dollars in damage, which are no longer being considered rare or the worst case scenario for these communities. And Charleston additionally is important given that floods under high tide and king tide scenarios, which are normal occurrences in that region, which makes flooding adaptation especially critical. So what is event-based scenario planning? Well, first off, scenario planning in general is a strategy that we use to provide plausible future outcomes of climate over a range of different inputs. So different emission scenarios result in different sea level rise scenarios, for example. And then event-based scenario planning takes those range of scenarios and a range of plausible future outcomes, and additionally adds a range of extreme weather events on top of that. So we can look at the changes in sea level rise and how that's going to affect historical hurricane if we were to look at it in 2030, for example, like Hurricane Harvey, how much more inundation or how much more storm surge will occur given sea level rise. So Glisa goes through this process of scenario planning. They don't do event-based scenario planning. And a few of the steps that they take that are key to mention in their process of scenario planning is gathering location data, location-specific data and models, and inputting those into their scenarios. So they take care to look at what information is actually relevant to the location and interpolating information if necessary, and taking this information to put it into scenarios which are presented to community members and decision makers that are actually involved in the locations of interest, with the goal of making sure that we are doing our best to avoid detrimental and unwanted outcomes of these scenario plans. So the communities themselves have the option to contribute what they believe are the goals or the explicit vulnerabilities of their region into the scenarios to make sure that those are accounted for, and in the end, get to choose which scenarios they move forward with to make their adaptation plans. So why do we do this? What is the reason why we do these ranges of scenarios instead of just picking one and running with it? Well, so climate models that we see right now can currently interpret near future scenarios and current data on broader spatial scales, but often are not for small regions and include like global projections and predictions, and also rely on an incomplete knowledge of the climate system. So like, for example, they don't, cloud modeling is very complex and not typically included in sea level rise projections, because why? Anyway. Also, these typical climate models only use high probability and low uncertainty projections, which leaves communities especially vulnerable to extreme weather events and low probability events like hurricanes that we can't predict when they happen or how heavy they're going to hit a community in like 10 years from now. So with all that information, with the lack of information about these explicit extreme events or higher uncertainty projections, we want to make sure that we can address this uncertainty address the uncertainty and the lack of information by providing this range of scenarios again. So making sure that communities can be prepared for more extreme events. And we do this without assigning statistical significance to the outcomes of these events. Once again, if you provide a range, you just want to make sure that they are prepared for something should it happen, instead of prepared for, yeah, I don't know where I was going with that. Anyway, We want to also make sure that communities have the capability to manage their uncertainty and evaluate potential trade-offs and co-benefits, which is why in the end they get to choose which scenario they move forward with in making adaptation plans. And this little thing shows right here situations in which scenario planning is more useful versus when it's not. So scenario planning is especially more useful when there's a large number of complex issues and variables and potential for unforeseen variables like hurricanes. Additionally, it's more useful on longer timescales with higher uncertainty, and when there's less agreement on adaptation approaches or less relevant information. So what have we focused on specifically in this project? I'm talking a lot about like what the actual method is instead of the implementation of it, which is intentional. My project is more focused on looking at it and understanding it rather than actually implementing it. But I did mention that there was a past master's project that did scenario planning in South Carolina. So they used 4 different hurricanes with 4 varying sea level rises to predict storm surge and inundation in 2030 in South Carolina. And Lisa is going forward with this scenario planning project over the next couple of years. Not actually doing event-based scenario planning, but will be helping to identify risks to Michigan communities and communities along the coast of Georgia. And potential continuations of this project, we did this sort of thing in our projects last year, so I just thought I'd include it anyway, especially because this is sort of an open-ended thing that I'm leaving with. Actually implementing event-based scenario planning, I think is a critical thing that we should be doing for risk analysis in virtually every community everywhere to make sure we understand significant climate threats. Developing a guidebook for event-based scenario planning. Lisa currently has a bunch of guidebooks for regular scenario planning, which if you're interested, would definitely recommend reading. And there's also a bunch of groups around the globe or the world that work on this. So like Arizona, Australia. And I think, communication between those kinds of groups to make sure that we understand what's really beneficial and working alongside those groups with students like us would be a good idea. And that is the end.